Got two more examples. First of all, f of x equals e to the negative 2x cosine of 3x. Find the Taylor series for this one centered at a equals 0 and find its interval of convergence. We could take derivatives, but that would quickly get nasty. With the first derivative, we need the product rule and the chain rule, and then we get two terms. And then with the second derivative, we'd apply the same things to both of those terms and get four terms probably. Yeah, I don't want to do that. Is there a better way? Use the series for e to the x and cosine of x, substitute negative 2x and 3x, and then multiply the series. Is that really better? It is. Might not sound better, but it is. The series for e to the x starts out 1 plus x, but replace x with negative 2x, plus x squared over 2 factorial, replace x with negative 2x, plus x cubed over 3 factorial, replace x with negative 2x. And the series for cosine starts out 1 minus x squared over 2 factorial, replace x with 3x, plus x to the 4th over 4 factorial, replace x with 3x, etc. Maybe we don't want to try completely figuring out the pattern here. Maybe, yes, it will typically be good enough to figure out, say, the first 3 or 4 non-zero terms, and then just put plus dot, dot, dots. As far as actually multiplying, well, let's simplify first. Do it the same way we did when we squared that series. But let's simplify first. I'm simplifying in my head here. Just double check in your own mind what I did there. Negative 2 squared is positive 4 divided by 2 factorial is positive 2. Here, negative 2 cubed is negative 8. 3 factorial 6. Negative 8 over 6 is negative 4/3. Here, I'm going to get a 1 minus 3 squared is 9. 2 factorial is 2. 3 to the 4th is 81. 4 factorial is 24. Now multiply these. I will take the 1 here and multiply by everything. So I will put everything down here. And I think I'm going to put a little bit more space in between these. Because, okay, so there's a really long minus sign there. Because I'd like to line things up vertically again like before and line up like terms. In the next line, it's going to be odd powers of x instead of even powers. Just a little bit more space in between these. Okay, next line, negative 2x times everything. Negative 2x times 1 is negative 2x. Put it in here. Between the 0th power and squared term here. Negative 2x times negative 9 halves x squared. That'll be positive 9x cubed, right? The negative 2's effectively cancel. Positive 9x cubed, put it right in here. Then negative 2x times that is going to be negative 81 over 12, x to the 5th. Yeah, put it right around here. Okay, don't do any more. Go to this term, 2x squared times 1 is 2x squared. Put it underneath the other x squared term. Then this times this, the 2's cancel. Looks like we get negative 9x to the 4th there. I will write one more. 2x squared times that is going to be plus 81 over 12 x to the 6th, etc. Let's at least do the first product here. Negative 4/3 x cubed times 1, negative 4/3 x cubed. And I think I won't bother with more. This technically goes on forever and ever. Simplify by combining like terms. 1 minus 2x. Okay, now we need to do a little fraction work. Negative 9 halves plus 2 is negative 9 halves plus 4 halves is negative 5 halves. Looking right there, that gives me minus 5 halves x squared. Let's also do the 9 minus 4/3 for the x cubed terms. That'll be 27 minus 4/3, 23/3. Looks like that's the coefficient of x cubed. Hopefully I have not made a mistake. Let's just do plus dot dot dots from there. Check it. Series. The function is e to the negative 2x, use a capital E, times cosine 3x. We are checking through that term there. It looks like it's right. Okay. Where does this converge? It converges over the interval that is the intersection of the two intervals of convergence, intervals of convergence for these things. But they both converge for all x. So the product converges for all x. This is true for all x. Final example. What is the series centered at a equals 0 for the tangent function? At the very end of Monday's class, we did arctangent by integration, actually, if I recall correctly, integrating 1 over 1 plus x squared. But what about the tangent? Use the fact that it's sine divided by cosine by definition, and then use the series for sine and cosine, which, you really should remember the series for e to the x, cosine, and sine, and 1 over 1 minus x for the rest of your life. Okay, really, it's a cultural thing. Everybody should know those things. I mean, don't be snobbish about it if you encounter somebody who doesn't, but right, that's never a good idea, because to tell you the truth, most people don't know these things. But in reality, you should. Okay, it's just a cultural thing. Everybody should know these. It is a part of our modern world, and it is related to high technology, the fact that these things are true. So what do I have to do? I have to divide the series? Yes. How? Polynomial long division. Infinite polynomial long division, which is not quite as bad as it sounds. I will also simplify the factorials here. We can do this in a few minutes. It's not as bad as it sounds. We're just going to find the first 3 non-zero terms. I'm dividing the cosine one into the sine one. With dot, dot, dots. Putting the answer up here, and the answer up here is going to be the answer for the series. What do I have to multiply 1 by to get x? Oh, that's easy, x. Now take that and multiply it by everything over here, put the answer under there. X times 1 is x. X times negative 1/2 x squared is negative 1/2 x cubed. Line up the x cubes. X times that is going to be plus 1 over 24 x to the 5th. Line up those x to the 5ths. Subtract. The x's cancel. Okay, more work with fractions. Negative 1/6 plus 1/2. Get a common denominator of 6. That's 2/6 or 1/3. So this becomes 1/3 x cubed after subtraction. And I also have to do, it looks like 1 over 120 minus 1/24. Common denominator of 120 will give this. 24 does go into 125 times negative 4 over 120, which is negative 1/30. Negative 1/30 x to the 5th. What do I need to multiply 1 by to get 1/3 x cubed? How about 1/3 x cubed? Oh, I know why something's wrong. I think it's right, but I still have to subtract. Now multiply 1/3 x cubed times everything here and put the answer under here. Don't forget your dots like I did there. Subtract. One more fraction calculation to do. -1/30 plus 1/6 is -1 plus 5/30. That's 4/30 or 2/15. That looks good. So I get a 2/15 x to the 5th plus ... Now, finally, for the third non-zero term, I need to multiply 1 by 2/15 x to the 5th. That is the next term. I'm not going to bother doing any more. Plus ... All that goes up here. It equals tangent of x. What is the interval of convergence? Without proof, though I hope it seems reasonable, the interval of convergence is a finite interval from -π/2 to +π/2. Why? Because that's where the tangent function has vertical asymptotes for the piece that goes through the origin. I'm not going to prove that, but it should seem reasonable that you would not want to go through those vertical asymptotes. Did I do it right though? Series, if I can spell, series tan x. Yes. Compare. I got the right first three non-zero terms.